Okay, so here we have an example where the t-chart is already made for us. And when I'm looking at this, 1 minus cos squared theta equals cos squared theta times tan squared theta, it's not quite so clear which side's more complicated. Usually I like to start with the more complicated side. One thing that jumps out at me right away is this left-hand side. Here, I'll just copy it out again here to get started. This left-hand side, again, if I look at sine squared theta plus cos squared theta equals 1, and if I subtract sine squared theta from both sides, if I subtract cos squared theta from both sides, so if I subtract this from that side and from this side, you can see that 1 minus cos squared theta is equal to sine squared theta. So I can make use of that right away, and I can say that is the same thing as sine squared theta. So I'm going to just do a little bit of work on the left-hand side. Then I'll go to the right-hand side. Here, I'll just copy out the first line just to get started. And I'm going to go with that strategy of taking that tan squared theta and breaking it up. Cos squared theta times sine squared theta over cos squared theta. Well, now we're almost done, aren't we? Because now I've got cos squared theta over cos squared theta, so that cancels out. So then I get sine squared theta. And I have left-hand side equals right-hand side. There are a few instructors that say that you should only work with one side and not the other, and only work with the left-hand side. So like if you were doing that, you could say sine squared theta now, and you could break that into 1 minus cos squared theta, and now say that this is the same as the original left-hand side. I don't worry too much about that. I think you can work both the left-hand side and the right-hand side, and as soon as you can get the two to agree, then we're okay. Taking a look at E, here first I'll just copy it out on the chart. So again, we need to make a decision about which side we're going to start with. I think I'm going to work with the left-hand side first, and that cotan theta I can change into cos over sine. So it's going to be cos x over the sine of x. Just going to make sure that this fraction bar looks bigger than the other one. Now instead of dividing by that, I'm going to be multiplying by the reciprocal. So I'll get cos squared x times sine of x over cos of x. So now I'm multiplying fractions. So, it's all, I would get cos squared x times sine x over cos x. And right away now I can cancel out because we're just multiplying everywhere. I can cancel the cos here, and since I've got cos x times cos x here, I'm just going to stroke out the 2. And then we're done, aren't we? Because now I've got cos x times sine of x. So I'll just rewrite it in the correct order. And then we're done because I got the left-hand side equal to the right-hand side. All right, let's take a look at our next example. All right, well, this looks crazy. Look at that. I got cos to the 4th power. So, really what this means, this is like cos of theta multiplied by itself 4 times. So that means the same thing as that. So I'll just start off by writing it out. Okay, so this cos to the 4th minus sine to the 4th reminds me a lot of my difference of squares. So just a reminder, a squared minus b squared, I can factor that and get a plus b times a minus b. So in this case, is cos to the 4th power, is that a square? It is a square. It's the square of cos squared. Like, for example, if I said cos squared theta squared minus sine squared theta squared. So this is cos squared, and then when I square it, remember how it works? Like x to the power to another power, I would multiply those two numbers. So that's the same thing as cos to the 4th. So I can factor this, and it's going to look like this. If I follow that same pattern, where a is cos squared theta and b is sine squared theta, I'm going to get cos squared theta plus sine squared theta times cos squared theta minus sine squared theta. And I just got a little bit past that line, but it's okay. All right, now just looking at that left-hand side, does anything jump out at you? And again, boy, how many times have we seen it? Again, it's this sine squared plus cos squared equals 1. So do you see an application of that? So if I go back here, it's in a different order, but it's the same thing. So cos squared theta plus sine squared theta is just equal to 1. So I'll emphasize that. I'll show that I'm not just forgetting to write it, but I'm going to put a 1 there. So it's times cos squared theta minus sine squared theta. Now I've got that equal to 1 minus 2 sine squared theta. So on the right hand side, I don't have any coses. On the left hand side, I've got cos squared theta. So just a reminder then, I could, again, using that same principle, if I was just to solve for cos squared theta, cos squared theta equals 1 minus sine squared theta. So, that's just an application of that identity. So if I go over here, I'm going to say 1 minus sine squared theta. So this part here has now become this, okay? And that, now I'm subtracting sine squared theta. Of course, when you're doing this on, on a test or assessment, you don't have a highlighter with you, and I can see, I can look at, cos squared, and they change that to 1 minus sine squared. Then I've got a sine squared theta minus sine squared theta, so I think it's pretty straightforward. I've got 2 of these minus sine squared theta, and I've got the left-hand side equal to the right-hand side. Nice, it's done. You know what I would say? It says for this, I would suggest before you're going on to the video. So I'm going to just stroke out this because I don't know what exercise 15 means. I would say practice the above examples. So that would be a good time before you go on to the next part of this lesson. Just either on another piece of paper or whatever. Just you could even just cover my answer with a piece of paper and see if you can solve it. And it would be good just to, if you could practice those and see if you can run through it. And if you get stuck, of course, you can look at the answer. You can even watch me go over it again. Okay, so I guess I'll see you in class. If you've got any questions, just give me a shout.